All right, good morning, everyone. My name is Miguel Rodriguez. I am a program manager at the ARM Institute. This is my first time being at the ROS-I annual meeting, so I would like to thank Matt Robinson for giving me the opportunity to be here and just going over some of the exciting work that we're doing at ARM. By a show of hands, who here is part of it's an ARM member or has been to our facilities in Pittsburgh? All right. That's a decent number. That's a decent number. A lot of the information we're gonna go through here will look very familiar. And since I know that I'm the last thing standing between you and lunch, I'm gonna try to get through this very smoothly. I'm gonna do my best Chuck Brand impression, and then just get through it really quickly so you guys can get to lunch. Also, heads up, if I start throwing around too many confusing acronyms or I'm moving too fast, please just wait for me, let me know, and I can slow down and go over things a little bit more in detail. So for those keeping score, the Advanced Robotics for Manufacturing Institute has been around for about 8 years, a little over 8 years now. We are one of 9 Department of Defense Manufacturing Innovation Institutes. And in case you couldn't tell by the color in our logos and all around our building, we're located in the Steel City, Pittsburgh, PA. So that's why the color scheme matches everything else in Pittsburgh. Our consortium includes 460 diverse organizations spanning universities, small startups, large OEMs, nonprofits, and federal agencies all around the United States. To date, we have received roughly 150 million in investments from the DoD and other federal agencies to support projects and resources aimed at improving the U.S. domestic manufacturing capabilities. A quick thought exercise for everyone who's here. I want you to think about the last time you tried to adopt a new technology, a new manufacturing process, just implement something new at your job. And I want you to think about some of the challenges that were known that you had to face going through that process. Our ultimate goal is, and which you will hear a lot more in this presentation, is to accelerate the development and adoption of innovative robotic technologies while also training and empowering the manufacturing workforce to take full advantage of these technologies. We're not just focused on supporting large companies, we're also committed to helping smaller manufacturers adopt robotics and AI to boost their competitiveness and strengthen the overall US manufacturing ecosystem. We approach this mission through 3 different fronts. First, we foster collaboration among our consortium members by creating opportunities to work together, most commonly through them participating on our technology project calls, and also through the different workshops and activities that we host at our facilities. Second, we reduce barriers to robotic adoptions by funding projects that help technologies cross the TRL gap 4 through 7, commonly known as the Death Valley. And also we also offer advanced manufacturing engineering services at our facilities, which I will go over more in details later. Finally, we empower the growing robotics workforce through roboticscareer.org, a platform that helps individuals connect with both training programs and employers across the country. We're trying to help the workforce get the right skills in order for them to be successful in the manufacturing area. Almost 3 years ago, through the Build Back Better, BBB, regional challenge from the Department of Commerce, the ARM Institute received funding to launch the Robotics Manufacturing Hub, RMH, and establish our in-house engineering team. Picture here is our engineering lab, which highlights the range of robotic manufacturing cells we have set up there. We have welding cells, we have grinding cells, we have different types of inspection cells, and a larger material handling robotic cell. We are hardware agnostic, so that's why you will see UR robots, Yaskawa robots, Fanuc robots, and all sorts of different hardware in our lab. We're trying to make sure that we're working with our manufacturers, working with the regional local manufacturers, and working with what they have to make sure that they're successful. The primary focus of our engineering team today is to support the mission of RMH, which is to de-risk robotic and advanced technologies for small and medium-sized manufacturers in the Southwest Pennsylvania area. By supporting these smaller manufacturers, we are not just helping them add capability and increase their capacity, we're also ensuring jobs remain competitive and secure in today's changing economic landscape. Through our funded projects and development initiatives, the ARM Institute is focused on advancing technologies that drive impact across 5 key areas. The first one being risk reduction for transitioning to the factory floor, human-robot interaction, interoperability, reconfigurable, agile, and flexible robotic work cells, and AI and intelligent robotic systems. These focus areas guide our efforts to ensure that innovations are not only cutting edge, but also practical, scalable, and ready for real-world deployment. As you can probably tell by now, technology projects are one of the core, most important parts of how we pursue our mission at ARM. Throughout the year, we offer multiple opportunities for consortium members to participate in funded technology development projects. To date, we have funded over 150 projects, nearly all of which require a one-on-one cost share, which means that the federal dollars that we're receiving from the DoD are having a higher impact with the one-on-one cost matching. It is also important to note that all of the deliverables and outputs from these projects are made available to all ARM consortium members. This helps maximize the impact and accelerate the adoption of these technologies across the whole consortium. I want to make sure I'm staying in time. Our standard process for the project call process typically begins with the release of a project call document, which outlines the technical objectives, the available funding, and other key requirements for the projects. From there, we begin accepting concept papers, which usually follow a predefined template and are about 5 to 6 pages in length. After reviewing the submissions, we do a down select to identify the concepts that best align with the goals and requirements outlined in the project call document. Selected teams are then invited to the presentation phase, where they have a chance to give a more detailed presentation about the proposal and answer questions from our reviewing panel. Following the presentation, the final project selections are made, and we begin the contracting phase. We use this multi-step approach because it allows us to efficiently evaluate a large number of submissions while also ensuring the strongest concepts are given the opportunity to move forward. Up until the end of last week, we had 3 active project calls running at the same time. The robotic inspection and for casting and forging is a directed project call from the Air Force. The funding came directly from the Air Force with very specific requirements and goals. We completed final selections for this call last week, or are now in the contracting phase for the 2 teams that we selected from that project call. This was an expedited one-step process due to the nature of the money that was coming in from the Air Force. They wanted to move really quickly. So the whole process from the release of the document to making a final selection was 45 days. So we moved really quickly with this. But don't worry, we still got more project calls going on now and later on this year. Right now, we have our regular schedule core technology project call with the aim, which we try to do about once a year and comes from our core funding. And we also have another project call, which is focused specifically on building a repository of AI-based manufacturing resources. For both calls, project teams are currently in the presentation phase. They're working on preparing the presentations, and we anticipate to make final selections on these project calls mid-June. Based on the feedback from our members and our government sponsors, the ARM Institute has identified several key manufacturing and technology areas we want to actively explore this year. AI for robotics and advanced manufacturing, the manufacturing of casting and forgings, the robotic manufacturing of garment assemblies, and there's some other DoD specific priorities. These focus areas reflect both industry needs and national priorities, guiding our current efforts to drive impactful innovation across the manufacturing ecosystem. The first area of focus emerged from a discovery workshop conducted by the ARM Institute a few years ago. This workshop led to the development of a strategic roadmap that identified 8 key AI technologies that the ARM Institute should be prioritizing for investment. Another quick show of hands. How many of you have experience using AI-driven solutions in a manufacturing space? There's a number of you, yeah. One of the main takeaways from the workshop was that high quality, usable data across various manufacturing processes is a critical enabler for developing and deploying effective AI-driven robotic solutions. Without strong data foundations, meaningful AI adoption in manufacturing becomes nearly significantly more challenging and almost impossible to implement. So you need good data to be able to implement these things in the real world. To address the need for high quality, accessible manufacturing data, the ARM Institute launched the AI Data Foundry program. Please don't look too closely at these charts. They're a little bit outdated and outside my range of expertise. The goal of this program is twofold. First, it's to collect manufacturing data by leveraging both ongoing and past performing ARM projects. The second phase is also to develop generalized robotic skills that can be trained on this data set, the data set that we collect, and be applied across a variety of different manufacturing processes and use cases. The long-term goal is to create a robust AI data resource that manufacturers of all sizes can access and utilize. By building this foundation, we aim to make it easier for non-experts to deploy AI systems within their manufacturing operations. Ultimately, lowering barriers to adoption and expanding the reach of advanced AI-driven solutions across the industries, which will be something really cool if we can actually get to see it in the near future. The ARM Institute has found that technology adoption is especially challenging in high mix, low volume manufacturing areas due to the inherent slim margins and high variability in these parts. These factors make ROI hard to justify and increase the risk to implement these newer technologies in the production floor. People that are running production do not want to implement new technologies because it's not well proven. So, how can we help them de-risk that? At the DoD's request, we engage our consortium and key industry partners in the casting and forging industry in a series of workshops to identify key opportunities for robotics in the casting and forging industry. The first use of the resulting roadmap that came out of this workshop guide the technical objectives for the project call that concluded last week. The plan is for follow-on funding to be used for more project calls to build upon the results from this project call and from the discovery workshops that we have conducted. Here's an example of a project led by Capson Robotics that was selected last year and currently it's executing, that addresses one of the challenges identified in the workshop for the casting and forging industry, which has to do with manual grinding operations. The goal of this system is to automatically identify the parting line in a caster part and generate the grinding path needed to remove the flashing without having much manual programming involved. This makes it easier for operators that are not programmers to use this technology and remove them from doing the dirty, dull, and dangerous work that it's normally found in this industry. Another industry facing similar high mix, low volume challenges is the garment assembly industry. The process of putting together a sewn good, your t-shirts, pants, jackets, everything like that, has remained largely unchanged since the 20th century and still relies very heavily on skilled manual labor, which is becoming more and more difficult to find. The ARM Institute has funded several projects aimed at advancing the state of the arts in robotic sewing, helping to modernize this traditionally labor-intensive industry and bring them out to the 21st century. We have partnered with key industry players on these projects to help us understand their needs and identify opportunities for improvements, making sure we're driving innovation and progress in the most impactful areas in robotic garment assembly. This is just showcasing how we collaborate with industry partners just to make sure that we're solving the right problems. As one of the DoD MII's, sorry, that's a mouthful, ARM prioritizes projects with dual-use applications, solutions that benefit both the industry, the commercial industry, and the defense industrial base. As a result, to further support the DoD, ARM recently secured a 5-year agreement to conduct research and fund dual-use technology projects of high interest for the Department of the Air Force. More details will be released about this funding later on this year, so be on the lookout for that. Where am I with time? Okay. All right. In closing, the future manufacturing is not just about technology. It's also about the people and how we empower them with the right tools to innovate and grow. That's our goal at the ARM Institute. Thank you so much for your time, and I'm happy to answer any questions.
Thanks, Miguel. Are there any questions for Miguel from the ARM Institute? I guess, actually, since he's got a minute or two, I would like to say, right, obviously, the government funding / industry collaboration, we've been on a number of teams. I know our friends from Ohio State, a number of others, so we've been able to collaborate. And one thing that's actually a beneficial thing is that they're very open to certain commitments back to open source. All right, so if you're interested in getting involved with the ARM Institute, I'm sure Miguel can answer your questions, but a number of us here in the room have taken advantage. There's a number of different ways to get involved, and it helps also support open or interested in interoperability. Hey, how often do you see on a slide a blue robot and a yellow robot working on the same part? Right, so that's kind of interesting things to think about, and it is a vehicle for which we've also supported a lot of our open source tools that you heard Michael talk about today. Where we can make commits back to move it and things like that, other open source projects, right? So thank you, Miguel, and thank you to the ARM Institute for enabling basically a focused strategic effort on industrial robotics. And yeah, it's been great working with you. Questions specifically for Miguel? Yes, Akash.
So I don't know if you mentioned on there, but does the ARM Institute have any plans to look at humanoid robots in the future as we see other countries start to ramp up?
So Akash is asking about interest, the ARM Institute specific interest in humanoid robotics.
Currently, that's not on the immediate roadmap, but obviously if that is something that it's of interest of the industry and specifically for the DoD, if it's something that becomes a high interest, then yes, I can see ARM following on the humanoid robotics.
I think what we see is the strategic roadmaps focusing very much on like capabilities. So if you look at those specific focus areas, if the right tool happens to be a humanoid, you might see someone propose such a thing. And obviously, if you have a DoD stakeholders like, hey, we have this thing that people are doing, and can we at least run a pilot with the capability of being humanoid? Those things sort of manifest, and those can be reflected in a specific call. Did I butcher that? Sorry.
No, you did amazing. Yeah, yeah.
Any other questions for Miguel? Yes, over there, Magna.
Do you have any plans for open source?
Sorry, any plans for?
Doing any open source contribution?
Yeah, so when we're asking for deliverables for the projects, if one of the deliverables is addition to open source software, that tends to be normally a pretty positive on the proposals. So yes, we're always actively trying to make sure that the work that we're doing has the highest, the largest impact. So yes, open source, to Matt's point, it's something that's a high priority for ARM, and want to make sure that the technologies we're developing are getting to the right hands.
At the same time, right, they do mention their consortium developed IP, right? So sometimes strategies or the tools there on the accessing, say, developed code in an organized fashion, those are still evolving. So sometimes for like code contributions, things that like say show up in like say Nether or things that get committed back and move it, they do credit that in your proposal. But obviously they still want some content to build the value of the consortium too. Excellent. Well, hey, we're heading into lunch.
Just one last thing, because I will get killed if I don't mention this. Before I forget, just a quick reminder that ARM is going to have their annual member meeting in September 3rd to 5th. That's the week after Labor Day. It's that sweet spot between the end of the baseball season and the beginning of the football season, if you're into that. So please come to Pittsburgh. We're going to have an annual member meeting. If you speak to anyone that has been to the member meeting, they will tell you that it's a very great event. And yeah, please come to a member meeting.